Welcome to day 4 of the microservices series. If you missed day 3 where we wrote the database code and models, the playlist link is below, but you can still follow along today. Right now, our user service works, but it relies on a toy SQLite database. This is not, of course, production ready. But in this episode, I want us to Dockerize our FastAPI application and swap the SQLite for a real PostgreSQL database using Docker Compose. By the end of this video, you will have a professional containerized environment. First, we need to untether our code from SQLite. We cannot hard code the database URL if we want to dynamically switch to Postgres in Docker. We will use Python's OS module to read an environment variable, falling back to SQLite only for local testing. So at the top, I'll say import OS, and then I can minimize this, and I'll create a constant called database URL, which will be equals to os.get env, and then I'll pick the key from the environment called database underscore URL, comma, the fallback will be the SQLite database. So I'll copy this and then pass it right there. Oh, I copied the entire code, so I can simply remove what I had before and paste, and that's it. So one more change can be made. I can call this, instead of engine, I can say, actually I can leave engine here and say my connection arguments, I'll say connection args will be equals to, I can copy this entire dictionary, cut it out and paste right there. So engine will be equals to, first of all, pass here the database URL, and then we can now pass the connection args. SQLite is built into Python, but PostgreSQL requires a specific driver. We need to install PG to allow SQ model to talk to Postgres. We use the binary version to keep our installation fast. Go to the terminal and say uv add PG. I don't know how you pronounce this. Please let me know in the comments. Binary, and then -- package user dash service, then hit enter. Be patient with it. Okay, it took some time, but it's now done. If I get to pyproject.toml, you can see we have the PG binary added as a dependency. Create a file named Dockerfile in the user service directory. So I'll get here and say Dockerfile. We are going to use multi-stage builds to keep our Docker images tiny and secure. So ideally, I'm going to have 2 stages. So the first stage, I'll call it stage 1. This can be called the builder. Okay. And then I'm going to have a second stage. The second stage will also have a name. Okay, I'll just say stage 2, the final stage. Okay, this is just for you to understand, and also maybe when you use your favorite AI tool to ask questions. All right, so stage 1, the builder, and stage 2. Stage 1 is going to be responsible for using the official UV image to rapidly install our dependencies. Then after that, stage 2 will take only the compiled environment and our code, leaving the heavy build tools behind. Because the heavy build tools like UV and the OS stuff always happen in the first stage. And after that, in the second stage, to make a small final image, we simply get what is from stage 1, which will only be what has been compiled, a compiled environment in our code. So let's get into it. So here at the beginning, I'll start by getting an image which has a Python image with UV, and we're going to use it. And so to do this, I'll simply say from. So from, like you can see the suggestion, okay? You say from, then you mention your base image. It's a very common syntax that is done when you want to create a Dockerfile. And this is exactly what I'm also trying to do. So by the end of this, yeah, you'll have a good grasp on what I'm trying to do. But essentially, this first line is going to say, I want to start with an image which has UV, okay? And like I've told you, UV is a very fast Python manager, okay? Start with an image that has UV pre-installed. So let's go ahead. So that will be, so I'll have this code in a link in the description so that you can click on it and go to GitHub and copy it. You don't have to type this by hand. So it will be ghcr, come on, what's happening? ghcr.io / astro -sh /uv / not / but full colon python 3.12 bookworm slim. Okay, let me minimize this and close this. Okay, so let's see from ghcr.io / astro -sh /uv python 3.12 bookworm slim. I should have actually just copied this and pasted. Okay, then we shall give it an alias, say as builder. Okay, as simple as that. So yeah, think of it as the name of this build stage, like you can see in the docs that have just appeared in the editor. Then after that, I'll go to the next step and create a working directory. Okay, I'll say work da. Okay, then remove that and say /app. I'll use lowercase. So this is going to create a working directory called app. And everything we're going to do going forward in stage 1 will be in this working directory called app. So the next thing is now to copy the dependency files first for Docker caching. So I'll copy and say PyProject. We want to copy the PyProject. Have I forgotten the spelling of PyProject.toml? PyProject.toml, and then uv.lock, okay, to the current working directory. So PyProject.toml, uv.lock. If there's any mistake I've made, I think I'll just have to review at the end. Maybe I can put a simple comment here. So I want to copy the dependency. I kind of feel I'm getting slow at typing. Maybe I should do a typing exercise one of these days for Docker caching. So that's what I want to do. After that, I am going to go ahead and copy the specific service files. Then after that, the next step will be to install dependencies for the user service. Okay, then after that, we shall copy the rest of the code, copy the rest of the code, and then move on to stage 2. Okay, so now to copy the specific service files, I simply say copy. So copy is a keyword in Docker. copy to be services / user dash service / pyproject.toml. I'll copy this. So if this is a wrong spelling, I'm gonna suffer. Then to services / user dash service. Simple start. So this is from our current working directory to what is in the container. After that, we can now install dependencies. To install dependencies, we'll use the run command. Say run uv sync -- package user dash service for space -- frozen -- no dash dev. Okay, and by doing that, we shall have installed our dependencies. Then we can now copy the rest of the code. I say copy everything from the current working directory on our host machine to the container. As simple as that. Now let's move on to stage 2. Stage 2 will be built from a fresh image. So I'll say from Python, I think 3.12 Slim bookworm. This should do. So this is going to be the base image. Okay. After that, I can now move on and create the same working directory like we had above. I'll say working directory will be / app, and Docker will change into this working directory. Then maybe I should put a few comments like I did before. We're going to copy the environment and code from the builder. Remember, the builder is what we called stage 1. Then after that, we shall put the virtual environment on the path, so that in case we have commands like FastAPI, okay, and any other command, okay, like QV, the system knows to look inside that virtual environment for any of the commands concerning Python, FastAPI, or UV. That's why I want to make sure I put it as the second step. Then after that, the other thing I want to do is, I think I can now run the application. This will be run the FastAPI server. Okay, as simple as that. So I'll now come here and now copy the environment and the code. So to copy, I still use the copy keyword. So by now you should see several, not several, but how I repeat these commands, okay? You should know what from now does, what work that does, okay? From is for your base image, workda for creating a working directory and changing into it, copy for copying files, run for running a command. So I'll say copy, and I want to copy -- from equals to builder. Okay, so this means we are copying from the first stage, from stage 1. So from builder, to specify the stage you're copying from, you simply use the -- from option. Then you say from builder, we want to copy everything in the app directory to our own app directory. Do you see how simple that is? Not complex. Then what else can we do? We'll create some space, and then we can now put the virtual environment in the path. To do that, simply say env. Env is used for setting environment variables. So you see it says key value. We put key value pairs. In my case, the key is going to be path. Okay, and path, I am going to put 2 quotes and say /app /.venv. Remember, if you look at our project, we have a .env. Okay, not en but .venv. So even in the container, we shall have it. Okay. So dot v env / bin. Okay. Then full colon. Okay. We put the $sign, then path, like that. Okay. So by doing this, we are simply putting the virtual environment on the path. Okay, so I hope this looks okay. I will now go on to the last step in stage 2 and run a command. Okay, so you can say cmd to run a command, cmd. Okay, then we shall run the command. Okay, so like you see, the documentation says this helps us to set up the default executable for this container. So if you want to execute this container, this is what you do. Okay, so we are setting the default executable and parameters for executing this container. Okay, then I can come here and say the command will be FastAPI, okay, comma run. Okay, is the next command, comma, then we say services / user service, is that correct? / main.py. Okay, when we are done, we can now pass arguments like minus port. Okay, and the value for that for port will be, can put 8000, okay, or 8001 like we had earlier. And yeah, another value you can put is the host, by the way. For the host minus host, the value can be 000. Okay, so we are binding 00 for Docker, so it will be, I think there are always 4 values. Yes, 1 2 3 4, as simple as that. All right, so I think this makes it for the Dockerfile. I don't know why we have a squiggly line, but I will, yeah, this can do for us. In case of anything, yeah, we shall edit and make it better. Create a file named compose.yaml at the root of the project. So I can now go to the root. So let me move on to the root, and then I can call it compose dot, like that. And then inside here, we're going to create a service, okay, or a database container, because right now we have a user service container, but it needs a database container to talk to. So we're going to use Docker Compose to orchestrate them. Okay, so we're going to define our API and a Postgres database. And we're going to pass the database URL environment variable to our FastAPI app to override SQLite. If you remember, we talked about db.py, where we have our environment variable called database URL. So we have to pass it to override SQLite. So let's work on this. And it's very, very simple. Okay, so let's do it. So the first thing is to have a services block. And after that, you can now name your services. Okay, the first, so I'll hit tab, then I'll call this user service, like that. After that, put a full colon. Okay, and then go to the next line, tab, and say build. Okay, full colon, tab, and put the context. Okay, so the compose file is going to be in the current working directory. Okay, so I'll put a period to mean the current working directory, and then the Docker file. Okay, the Docker file will be located in services / user service / Docker file. As simple as that. Then our API or the FastAPI app will run on ports. Okay, so ports, I'll say externally it will run on port 8001. Okay, and internally it will run on port 8000. As simple as that. I made a mistake. I have to remove this code. So this first one is for external. The next one is internal. In fact, here I should now change this to 8000. Okay, for internal. Okay, simply port mapping, internal to external. Then for the environment, okay, the environment also we have a full colon after that, and then a tab. Okay, I just hit enter and auto completed to accept the suggestion by the editor, but this is good enough. So we shall have key value pairs, the name of the environment variable and its value. In our case, it's going to be database underscore URL, and the value will be PostgreSQL. I should have copied this also. It's easy to make mistakes when you're typing out these kind of small things. Postgres plus psycho PG. Okay, I hope this is the correct spelling. If it fails, I'll debug. Then Postgres, full colon, then you put the password at DB. DB is going to be the host of our database. It's going to be called DB, and you'll see it in a minute. Then the port 5432, which is the default port for Postgres, /user DB, the name of the database. So maybe let me run through it just to make sure I'm correct. So it is PostgreSQL plus psychopg / two forward slashes after full colon, then Postgres. Okay, so Postgres is the user. Okay, full colon, the password at DB, the host of the database, then the port number, name of the database. Awesome. So for our application to work, it must first of all need a database. Okay, so I don't want this to work except when it has a database. So I'll say it depends on a service, another service, and that service would be called DB. Okay, so DB is going to be a service we're going to create. So I'll just indent this. Okay, then come outside here. Okay, and create, look at the indentation. Okay, all the services have to be on the same line of indentation. So I'll create the service DB, go the next line, hit tab and say image, full colon. I want to deal with Postgres. Okay, Postgres image, and the tag is 16-alpine. So if you go to the environment, okay, DB, okay, is referring to this service. Even here when it says depends on DB, is referring to this service. So the database will be started first, okay? Then our FastAPI user service. After that, we can specify the environment also. So Postgres needs a number of things, okay? Like the user, the password, the database, okay? So I'll remove this. It has keys like Postgres underscore user. Okay, in this case, I'll keep it to the default, okay, which will be Postgres. Then you can have the Postgres password, Postgres underscore password. That will be still password, okay. Then after that, we shall have the Postgres. Let me just paste and then change to Postgres DB, which is the name of the database, which is user underscore DB. That's why you see right here, it said user DB. Okay, and the password is code password, and the user is Postgres. So this value matches this, this other value matches this one, this other value matches this other one. Okay. Then the ports, okay, for the ports, I'll say ports full colon tab, it will be 5432 5432. Okay, internally and externally. Then we shall have a volume. Okay, so for the volume, it will be a named volume, and that volume will be called Postgres underscore data. Okay, and it will be of course Docker managed, and it will be mapped to var /libs /PostgreSQL /data. So volume outside the on the host, then this one inside the container. Okay, and it's a named volume, meaning it will be managed for us by Docker. Then we need to declare this Postgres data volume by saying we're going to create a volumes section, okay, or block. Go to the next line, hit tab, and say Postgres data. So by doing this, we have declared this volume called Postgres data. Look at the configuration I have highlighted. I had coded the database password directly into my compose configuration. This is okay for a YouTube tutorial. If you push this to GitHub, trust me, security bots will scrape that password in seconds. So make sure in a production environment, you use a .env file and reference it in your compose file. Never commit passwords to version control. This is just for learning purposes. If you want to know how to do that, okay, probably I can show you at the end. If you need to know how to do that, leave a comment. But I know by the time someone is watching a video on microservices, I know they know about ENVs, they know about Docker, they know about FastAPI, Python, virtual environments, and so many other things. Okay, I'm just showing you how to organize FastAPI applications as microservices. If you're new to Docker, I suggest you look up YouTube for a quick tutorial on Docker, but you need Docker Desktop. Okay, so download Docker Desktop for your machine, and after that, make sure it is running. Then go to your terminal. So I'll clear my terminal and then run docker compose, then pass an option called --build and wait a few seconds for the containers to start. Okay, it says unknown flag build. Oh, sorry, I missed something. It's supposed to be docker compose app. Okay, so --build is an option for app. Then hit enter. Says services.db.environment unexpected type map interface. Okay, time to debug. So I took some time to think about it. It says services, okay, which is this first block, then .db, which is this, .environment, which is this section, unexpected map string interface. I think it has to do with how these are defined. Okay, so I have to remove, I think, the quote. So I can either do this. I think when you put these dashes, then you need the equal signs here when defining the environment variables. So let me remove this, because I think in Docker Compose, if I say dash, okay, then I have to put an equal sign. I kind of think that's how it works. Okay, you have to choose one of those ways when defining your environment variables. So I'll put some space. Okay. Okay, now clear the screen and please wish me luck. Let's build. Okay, happy days. Out of curiosity, let me scroll up and see what I did here. Okay, here I put a dash. Yeah, so you see this way, you put a dash, the key equals the value. Okay, so you can either choose a dash with an equal sign or just the key full colon and then the value. So let's give it some time. Okay, give it some time. We have to wait for a few seconds. It will depend on how fast your machine is, your internet. Okay, yeah, let's wait and see. Okay, it's done, but there's another issue. It says error response from daemon failed to set up container networking. Driver failed programming external connectivity on endpoint fast store DB. Then it says bind for 005432 failed. Port is already allocated. Okay, yeah, I have a number of Dockerized tools. Maybe let me try by saying Docker compose down to bring down all. Okay. But then after that, I can maybe change the port. Okay. I can say 54323. Let me try this, and then also here change the external port to that. It's like the point of connection. Okay. Then run Docker compose up. Don't think I need to build anymore. Okay. So if I expand this a little bit, yeah, we can see that error is not there anymore. So yeah. Right. So now, yeah, maybe time to, yeah, to test it. This is good. So let's go to the browser and try to test that endpoint. Okay, it's not working. I probably need to rebuild. Okay. I'll just say up, build. Okay, it fails again. Looks like bugs love me today. I think we're running this using UV. Okay, so it has to be UV run. Okay, so comma, I'll say UV run because we're using UV to manage. Sorry. Save that. Okay. Break this. Try to rebuild. Hopefully this time there's some success. Yeah, this is how you learn, by failing and redoing. Okay, it says bin sh UV not found. Time to think about this closely. Wait, I am just confusing myself. Do you know that in stage 1 we left UV behind? Saying UV run is wrong, and of course UV not would be not found. So I have to remove this. Let me look at this command more carefully. Wow, look at this full colon. It's supposed to be a comma. This is crazy. So let's try to run this again. Looks like I'm just shooting myself in the foot by not giving more attention to the details. Okay, this is a beta error. Says up venv bin first no such file or directory. Okay, now this is beta. Yeah, this can be solved actually. After careful study, I discovered the solution and a number of other issues which I had not noticed. First of all, I think this line 15, it copies everything. And that means the venv, okay, from my machine is copied to the container. But the challenge is that this virtual environment has Mac binaries, okay, because I'm using a Mac OS. If you're using Windows, it will have Windows binaries. And yet, the containers we're working with are Linux machines. So always the fast API not found error will always exist. So to stop this, I quickly generated a Docker ignore, okay, using AI. I asked AI to generate a Docker ignore and include common things which are ignored in the Docker ignore file. So by doing this, this .venv directory will not be copied, okay, to our Linux machine. It will stay on the host Mac machine. But now inside the Linux machine, okay, we shall have it being recreated, okay, because of this UV sync. It will be recreated and we shall have an actual Linux binary, okay, in the container. So that is how I fixed that issue. Then I discovered another challenge. The first one is in this db.py. Earlier on, I only had code saying, it was saying connect args equals to this, okay, equals to this dictionary. But remember, this is only SQLite specific. With Postgres, it causes issues. You can try it out and see. So to handle it, I simply have connect args being equals to this dictionary only if the database URL starts with SQLite. Otherwise, it will be an empty dictionary. That's the first thing. Also, actually, before I discovered this issue, I also noticed that I said connect args only here. Okay. And yet create engine expects only one positional parameter, but now it was getting two. So it has to be connect args equals to connect args, like that. Then now you can run Docker Compose app. Okay. Of course, for your case, you have to build. Run Docker Compose app -- build. So you can see that the service is now working as expected. So let's go to the browser and check this out. So you see the docs are okay. Our application is running perfectly fine.